Hello, welcome to Pre-Calculus. Go ahead and open your books to lesson 5.4. We're going to go ahead and continue with tangent graphs. Now we're going to deal with periods, and we're going to deal with the shift in the periods there. If we look over here, move it a little bit. If we look over here, the steps, again, you find your period. It's radians divided by b, or if you really don't like this, you want to convert everything into degrees, that's completely fine. So that means it's 180 divided by whatever your b is. To find your asymptotes, that means your start and your end of a period. It's negative radians over 2b to radians over 2b. B is always that number in front of x. That's a change in the periods. Here, 3, we're not going to divide into two parts so we can see the wave of the graph. If you notice for sine and cosine, we needed 4 parts because we need to see that wave. For the tangent, we only need to divide into 2 parts because it's just kind of like a sideways wave. After that, then you have your negative a, your 0, and your a. And what we're going to add into this lesson is the shift change. All we do is simply add the shift change to each of the equations in the very end or in the beginning for 2 parts. Example 2a, y equals tangent of 2x. So now we have a period, it's being affected. First step, radians divided by b. So radians divided by 2, and you get radians over 2. Or, we're converting everything to degrees, 90 degrees. That means your period is from 90 degrees. 2, you have negative radians over 2b. In this case, our b is 2. 2, negative radians over 4, 2 radians over 4. That means we start at negative radians over 4 and we stop at positive radians over 4. That's where we start, that's where we stop. If you want to add more graphs to it, I just think that main one in the center. You can add one to the left, one to the right of it. Honestly, I'm just looking for that main one. Third one, we have to divide that into 2 parts. To do that, you multiply by 1/2. It's like fractions. Negative 1 over 4 times 1/2. You get negative radians over 8. And then this one, same thing, positive. We're using each of these and multiplying by 1/2. You multiply by 1/2, you get positive radians over 8. If you put this in decimal form or in degree form, it's 180 divided by 8. You get about 22 point something, and you could put that on your graph here. That's fine. I'm okay with it. Here, so that means we're going to be focusing on the negative radians over 8 and the radians over 8. That's going to help us with our coordinates. So for the first coordinates, dealing with your negative radians, it's always your first one that you dealt with over here. Negative radians over 8. And then your negative a. A is a number in front of the sine, the cosine. It's multiplying into that trig function. In this case, if you look up here, there is a special number, and that number is 1. So it's going to be a negative of the a that you have. So you have negative 1. Center is always 0, 0. And the other one is your third coordinate, and that's always your second one here. Radians over 8, and then it's your regular a is just a regular 1. We look here, we have 3 different sets of coordinates, and then we graph right here. So I have it here. This is actually in intervals of 45 degrees. If you look here, we have radians over 8, that's like 22 point something. And then we have 45 degrees, radians over 4. Then you can add another 22.5, and you have that pattern there. Or I just did it in patterns of 90 with little spaces in between. So radians over 4, little space. Radians over 2, that's 90, space. 3 radians over 4, and that's 135. And I did the same thing on the other side. Now I look at this, negative radians over 8, and negative 1, that's going to be right here. 0, 0, that's our second coordinate, right there. Radians over 8, 1. And that's right here. We create a graph that looks something like this. And that's all you have to do. If you want to add more, what I do, I think it's the easier way. 1, 2, 3, 4, 5, 4. 1, 2, 3, 4. You can go ahead, draw another line here. This is my center point. I know it's 1 down here. It's 1 up here. It's like a pattern. Once you draw 1, you can draw the pattern of the other ones. You can do the same thing on the other side there. So it's 1, let's see, 1, 2, 3, 4, 1, 2, 3, 4. Again, it's a pattern. So here, one here, one here, and we have a graph like that. But I mainly need that center one. After you find that main one, you can easily make a pattern from the other ones. Use the same increments. Now for B, this is where it's going to have a shift change. First step, same thing, just like the steps over here. If I were you, I would screenshot it when you do your assignments. I did send you a link for, not a link, but a type of app. I forgot what's it called. I have it there. But you can scan it, you can email it to me. It looks a lot better. It's in PDF form, so it's easier for me to see. You can adjust it, change it, etc., etc. It's just more professional that way. Now, let's do the next one. Shift change. So that's all they're adding is this step right here. Again, if you don't like radians, convert everything to radians. Radians equals 180 degrees. Very easy to change. Doesn't have to, it just depends on what you like. Step 1, find your period. Radians over 2 divided by radians. So radians over 2 is equal to 90 degrees. That's radians divided by B from your first step over there. Second step, you find your asymptotes. That's your start, your end. So you find it by multiplying radians divided by 2 times B, which is 2. And then we have negative radians over 4 to radians over 4. This is the extra step. I'll do that in the end. But you have to add the shift change to it because your start and your end is at negative radians over 4 to radians over 4, but we're shifting it just a little bit to 45 degrees or the radians over 4. So what I do is, after I find my asymptotes, my start to end line, I'm adding the shift change to it. Remember, if it's x minus whatever it is, you're adding that to add that degrees to whatever you need to down here and up here. If it's x plus radians over 4, you'll be subtracting it. So think of opposite signs. Now, I added radians over 4, the shift change. So instead of having it from the original of these two, now we have it from 0. So if I were to draw it, it would be right there. 2 radians over 2. So it used to be from negative radians over 4 to positive radians over 4. It shifted to the right. Now we go on with step 3. We're going to divide into 2 parts and we go ahead and solve. Okay, I don't know where the video last ended. So from this point here, we have our new asymptotes. Third step is we're grabbing still our original 2 asymptotes. We're going to be multiplying by 1/2, and that would be negative radians over 8, a positive radians over 8. But now we are going to be, we'll do that step in the last one. So step 4, we have to do our negative A, our 0, and our positive A. Here we have our original point here. We're going to be adding radians over 4 to each one of these because we are dealing with the shift change. So then, negative radians over 8 plus radians over 4. That's what we had over here, the regular shift change. And then here is our negative A. Our A is a number in front of the tangent. In this case, it's just -1. Go ahead and close it up. And then we have 0. We're adding the shift change only to the x-axis. That's where it's only shifting. We're not shifting up or down. And then here it says radians over 8. We're also adding the radians over 4. So you're adding it to each coordinate. Remember, we're only dealing with 3 coordinates. Then we get radians over 8. We get -1. We get radians over 4, 0. 3 radians over 8. And this is a +1. So when we deal with this, we go ahead and graph it. And now we have the graphs here. This is our new asymptotes. Do radians over 8. Radians over 8 is somewhere around here. Again, I put it in increments of 45 degrees. So you can do increments of the 22.5, which is the radians over 8. Whatever you like, just make sure it makes sense. Here, radians over 4. I have radians over 8 and -1. So that's going to be about right here. I have radians over 4, 0. That's going to be about right there. And 3 radians over 8 and 1, that is between these two right here. I don't remember what it is. I had it written down. 3 radians divided by 8 is 67.5. So that's why I prefer doing it in increments of 45. So 67.5 is between these two, but I don't label it because I know it's between it, and that's fine if you don't. Just have your main increments. Now, you go ahead and you graph it. So you have that graph there, and you can continue on the left side and on the right side. If you noticed, most of the tangent graph are from -45 to +45 degrees, and over there, compared to this one and that one, is shifted just a tad. Now we're going to do the last one, which is the cotangent. I'm not going to go into the other ones. You don't see these a lot, and plus for the cotangent, they don't really explain it a lot, especially for the cosecant and secant. I looked into your Algebra 2 book. They only gave half an example of a cotangent, meaning it's not as important, but it's good to know. Now let's go ahead and graph it. Give me a couple moments to write this down. I will erase everything from this one. I hope you guys are having a good time staying at home, being diligent. Make sure you're finishing up everything you need to for your last year, or you can have your senior year again here, which I don't think a lot of you would like that. So we have example 3, just the last one. Y is equal to 2 cotangent of 3x minus radians over 2. First thing we see here is we can never have a parentheses with numbers, or actually, let me change that. We can never have a number in front of x. In this case here, we have 3x minus radians over 2. We have to change that. I'm going to factor out the 3. So that means when you factor something out, you're dividing. So if I do 3 divided by 3, I'm left with x. If I do radians over 2, or if I do 1/2 divided by 3, I end up with radians, or 1/6. So treat it like a fraction. So 1/2 divided by 3, that will give you 1/6, or it gives you radians over 6. You always include the radians, it always goes on top. Or if you're converting everything, I think this is 30 degrees, something like that. So we have this, we have our limits, we have the period, we have the phase shift. Now we go ahead and find each one. So step 1, this is very different from what we learned before with the sine, cosine, and tangent. This is like a brief understanding, just basic, simple explanation. We find the period first. So radians divided by b. That'll be radians divided by 3. This is considered 180 divided by 3, it's 60 degrees. So now, step 2, you find your start point, your asymptotes. So your start and your end. So we're not going to find everything, we're not going to adjust to it. For cotangent, it's different from the tangent. It's actually facing the opposite direction, and it starts right at 0 instead of starting at -45 and +45. It's 0 to 180. So here we have a period of 0 to 60. Now let's have our starting and our ending points, our asymptotes. To find that, all right, I'm still adjusting to these videos. We're going to go ahead and find our starting and our ending points. It's our asymptotes. We're going to go ahead and solve for that. Again, cotangent is a lot easier to find. It's not as specific for tangent, sine, and cosine. It's just a brief graph. Cotangent is from 0 to 180. So when we're starting, we use the expression here. So it's a 3 times x minus radians over 6, set it equal to 0 to find our starting point. So divide by 3. Basically what you're doing is solving for x. This is again 0. And then you add radians over 3 to both sides. If you want to convert everything to degrees, radians over, this is 6. And radians over 6 is about 30 degrees, I believe. And then you can just convert it, and that's fine too. So then you get radians over 6, that's your starting point. Your ending point here, so the same expression, but now you set it equal to 180. So it's not from 0 to 360 anymore, it's 0 to 180, which is radians over 3. Sorry, just radians. Now, let's go ahead and solve for it. You're solving for x the same way. So divide both sides by 3. You get radians over 6 equals radians over 3, because you can't really get it unless you're doing degrees. You can divide it. Then you add radians over 6 to both sides. And this will give you radians over 2. Radians over 3 plus radians over 6. Think of 1/3 plus 1/6 gives you 1/2. Now we go on, this is our starting point, this is our ending point, we go on and graph this. So here I'm gonna do increments of 30 degrees. So if you don't know how to start that with radians, I'll just follow along. So it's radians over 6, radians over 3, and then radians over 2. Negative radians over 6, negative radians over 3, negative radians over 2. My starting point is radians over 6. My ending point is radians over 2. If you were doing this in degrees, this is 30, this is 90. Now what we do is we usually have the negative a, 0, positive a. We don't have that for the cotangents. What we have to do is we have to find our asymptotes, but now we have to find our center point. So we're gonna start this all. Here from 30 to 60, or 30 to 90, we have to find a number that is right between the two. To find a number that's right between the two, you add 30 and 90, divide by 2, and you get 60 like I said earlier. So your center point is now 60, which is right here, excuse me. Now, you have your line on the side, your line on the other side. You can be more specific and find the measurement here. So like 30 and 60, you add that, divide by 2, you can get your number there. Same thing on this side, 60 and 90, add them together, divide by 2. Well, I'm not gonna do that here. For cotangent, it's the opposite of tangent. In this case here, before I start graphing, we have 2, which is always our starting point, ending point. So here it's 2, so that means 2 up, 2 down. For cotangent, instead of following the usual for a tangent, which is down, center, up, we're going to do the opposite here, which is up, center, down. We're going to go up at 2, center at radians over 3 over 60. We're going to go down and negative 2. So again, we have 30, 60, 90, a line on the one side, line on the other side. You're not going to put it directly on the line. That is just showing you where that shift is between the two. So then you start graphing it, and you end up with a graph like that. If you want to keep on going, you can do more increments. So here is another shift. So from negative 30 to positive 30, negative radians over 6 to positive radians over 6. This is your center. This is your sides here. You have one here in the center and down here, and you have a graph like that. And then negative radians over 2 again. So if you want to repeat it, you don't have to. You're starting with up, center, and down and negative 2. And then we have a graph like that. Easier, you don't have to be as specific. You just find your numbers by the range. You can put everything in degree form, but this is how you would do a cotangent graph. So you do have homework to graph a lot of a tangent. I didn't do any cotangent, cosecant, secant. You don't really have to do much of that. But I do have about 4 for tangent graphs. If you have any questions, make sure you let me know. Make sure you're turning these in. I love you guys. I miss you.